Hey everyone, my name's Alicia. I'm not sure if you recognise me already from the previous sessions, but to give you a little bit of context, I'm your online host. I'm also the UK co-lead of Climate Designers UK. So, do you miss summer and the festivals? So do we. So we have our final how-to, a debut behind-the-scenes film that covers the making of the mycelium pavilion, recently featured at the UK's biggest festival, Glastonbury, and at the Forwards Festival in Bristol. We have the maker joining us at the Design for Planet today, Simon Carroll from Temple Design Studio, who's going to introduce the film. We're going to watch it now, and then after watching the film itself, there'll be Q&A. So I do encourage you to put questions in the chat. I'll be there to kind of engage with you as well, and then I'll ask the questions, and Simon can answer these at the end.
So we're here today to visit Biome. We're going to meet the team and discuss the Haze Pavilion project that will be at Glastonbury Festival.
Biome is a multi-award-winning research and development-led company. We are driven by a very simple philosophy: to allow nature to lead innovation and only have a positive or regenerative impact on everything that we touch.
Here at Biome, my work revolves around utilising mushrooms and fungi as a biomaterial, so how we can use the skills they have out in the wild and bring them into the lab to form products.
We've been looking at set design, stage design, and temporary structures for quite a while here at Biome. We've been recognizing how the industry needs a very quick turnaround, and the materials that are being used can sometimes be quite toxic. So when Temple approached us to discuss the use of our mycelium product into the Haze Pavilion at Glastonbury, it just became a no-brainer.
I've been making sets for somewhere in the regions of 20 years, sculpting polystyrene, working in workshops doing fiberglassing, and the material presence there was always really impactful on people's health. Ultimately, a lot of these products go to waste, and then that affects the environment in turn.
Under the ground in every forest, holding all of the topsoil together, is the root structure of fungi known as mycelium. When grown within a confined space, it branches out into these really intricate networks, and those networks create air pockets that provide incredible insulating properties. They're also hydrophobic, which means that they can resist moisture into the material, and also have a natural fire resistance property, driven by how the organism has evolved over billions of years.
The beginning of the process starts with your little culture of the mushroom, so this could be one that you've taken from the wild. You've then grown it on a plate. Then once you've established that you're looking at the right mushroom, stick it in with this grain. The mushroom then uses that nutrition source, and once you've bulked it up there, you can mix it with your hemp shiv here. You stick that into the mould or the shape that you want to fit it in. You then stick it into the incubation room for 2 weeks, and out pops your product at the end, which is a wet panel. Stick it in the dehydrator to remove all the water, and you're left with a pretty lightweight panel product at the end.
So this panel here is made out of mycelium and hemp. Particularly, it's made out of the waste streams produced by the CBD industry. It's ready to be used in industry as an insulation panel.
The next 2 days we're doing an R&D workshop, testing for the first time sculpting with mycelium to replace polystyrene.
I've been invited along as a sculptor and professional maker and educator to explore the possibilities of the material and what we can and can't do with it.
It's really cool to be here today with all these different artists and designers and builders, makers. Everyone's collaborating a lot, which has been great. Having that construction knowledge in addition to like some of the biology knowledge. It's very multidisciplinary, which I really enjoy.
It's been a learning curve of how it would work in a structural way, but I think that's part of what today is about, so it can be built to withstand all the Glastonbury extremities.
It's really exciting. We're all on a level playing field because as a material we've never worked with it in this way before.
My involvement in this project is to be the data gatherer, with the goal of being able to understand the environmental and the social impact of basically using natural materials for creative builds, but specifically in a festival setting.
Team Love are interested in projects like this because we've always tried to be very conscious about what we can do to do better. We're trying to look at a new material and how that could disrupt the materials we have existing in our industry already. After Glastonbury, we're writing a report. The report is there for the creative industries to give all the findings from our projects, to say, if you want to use this material in the future, read this and you'll see all the things we learn about it.
Our aim for Glastonbury is to show our product in a new form, things that the general public interact with on a regular basis. But most importantly, we would like to use this as an opportunity to change the way that we think about products and materials. It's only an example of what we could be doing if we think more in the way that nature does.
Seeing the pavilion for the first time, it took my breath away. Exciting to see it in its total kind of form. Yeah, almost an emotional thing to see it in real life.
Very rewarding seeing people's reactions and seeing how excited people got about it.
The materials and the products that we create are just a manifestation of a bigger philosophy and a bigger aim to provoke certain questions within people. Why aren't our buildings made of mushrooms? Why aren't our cities built in tune with nature?
We've got huge problems in the world about using concrete and other materials. We can develop something new. That's incredible.
So I think it's a great way to get people to start understanding what you could do with mycelium. I'm wondering if we can build houses out of it. There's so many questions.
It made me think about this tension through the construction industry. All buildings should be made to last hundreds of years, extremely robust materials. Should we be building buildings out of, well, paper, or in this case, a material which in itself is degradable, reusable?
My hopes for the Hayes Pavilion is that the pavilion itself returns every year, and each year we create new ideas and put new ideas at Glastonbury which hopefully can have a positive change on our planet.
We're in a climate crisis. We have a limited amount of time before we hit an irreversible feedback loop, which sounds all doom and gloom, but like there's so many creative solutions that are creating hope and inspiration. And this is one of those.
Well, we need to have a shift really in how we see products in their lifetime. That's when we'll start seeing kind of the importance of degradable products. Once we get governments on board, more groups, more companies producing, then you'll start to see the shift.
The glorious utopia would be that we could use waste directly from festivals to be able to make mycelium panels that then can be reused at the festival. And that would make it a complete circular process.
It would be great to position the product into many different creative markets. I would love to encourage the industries that I've worked across within theatre, film, events, to start picking up and using the material.
If you have to spend a bit more time and a bit more money on something, maybe it's worth it if the end goal is actually sustainability of life on planet Earth.
I'm really hoping that the report will show that festivals can be a really strong force for good, because festivals are like micro cities, so you can really test new technologies, then you can scale it up back into society.
As a kid looking at the change you can make in the world, I've never thought that mushrooms could get us this far, and it's fantastic seeing science actually having a difference in the world.
When we first started, not even 5 years ago, we were being laughed at. We were seen as just a bunch of hippies playing with mushrooms and hemp. There is a hidden genius in nature that we need to shed much more light on. We discovered some of our mycelium strains are able to actually consume and break down plastic in a very efficient manner. We rendered polystyrene unrecognizable as a plastic within only 28 days. Our hope is to demonstrate how we can seamlessly integrate these radical natural biotechnologies into what we do on a daily basis. And I think there's something to be said about going back to learning from these ancient and indigenous cultures in order to address all of the challenges that we're facing today.
To document the process. So yeah, thank you very much for joining us, Simon, to introduce this. Do you want to tell a little bit about yourself, like a little bit of a bio to introduce yourself as well?
Yeah, sure. Great to see everyone online. Thanks for welcoming me here today. I am I suppose I'm a multidisciplinary maker and designer. I started out as a carpenter many moons ago, and I've worked my way through the creative industry, working more and more with different materials, steel, polystyrene, taking on different practices, fabrication, sculpting, and then was very blessed to get involved with set design we're 10 years, coming up to 10 years now, and I'm producing sets for outdoor musical festivals, Boomtown, Glastonbury, Love Saves the Day, Forwards, to name but a few. And it's kind of that journey sort of moved through me and these materials, and I think what sort of sparked the whole thing off was actually being in those situations and working in those fields and working in very beautiful natural settings and watching the very products that we were using, such as polystyrene, escaping across the fields and being like, this isn't right. You know, we're supposed to produce these events with leave no trace, and we're leaving tiny little beads of microplastic everywhere. So yeah, this project is that inspiration coming to life, really. I picked up on an Eben Bayer talk in about 2016, which was recorded back in 2010, about mycelium disrupting the packaging industry, and it really, it got my cogs turning, and here we are.
Incredible. Yeah, it's an incredible kind of case study to show the capabilities of mycelium. My first question is, how do you see the future of mycelium? Like, what do you see the use of this in other applications? I've seen it, for example, as an option in insulation, wall insulation, and different interior products as well. What are your kind of predictions for the future of mycelium?
I don't want to take away at all from the idea of it being a building insulative. It's got fantastic performance ratings, and I think Biome have been working very hard to make that happen. For me, I think it's a perfect circular material for single-use production options. So the creative industry predominantly, even if we eke out a set for 3 or 4 years across some of the most resourceful events, it's still destined to have an end of life. And I think that gives us an opportunity to still create these 3D embellishments and these deep details, but be able to compost it and put it and still treat it as a circular product, which is one of my real goals, is to really look at the circularity that can be put into the creative industry. And we are looking at, beyond mycelium. But yeah, I think it is that perfect tool. And I also think products that are encapsulated by fiberglass currently, a lot of them have polystyrene core. And I think those markets can be looked at. I keep banging on recently about the marine sector. The sea has the power to absolutely trash anything. And I think if we are using products that do have an end of life in a marine market, when we should be looking at things like, what's happening to those things at the end of their life. So, buoys, surfboards, all of these things, they are encapsulated polystyrene in a natural environment. So I think we do, these are the futures that I think we can see and that we should be pushing to apply it to. The material does have the capability.
Yeah, absolutely. Thank you so much. There does seem like there's a lot of incredible possibilities for mycelium. And yeah, I'm very excited about the future of it. So we have a few questions from the audience, and I very much encourage you to add your questions into either the chat or the Q&A specific function, and I'll try and get through as many as I can in the last couple of minutes. So one of the questions we have is from Oliver, and it's asking, how durable is the material? Could it be made hard enough to be used instead of concrete or something like for a skate park or a different application like this?
It's currently quite friable. The materials that are used as the base are a hemp shiv, which is coming out of, as Ehab says in the video, CBD waste streams. There are things that are being investigated. Some of the science I can't really discuss, but making those materials more durable and performing better. But the more dense it is, the more costly it becomes to produce. There are algae products, I believe, that are starting to look into bioconcretes, and they're very exciting because they're quite applicable to that sector. So it's looking at microorganisms as a whole rather than just the mycelia strain. Sure.
So there's a question talking about its application in homes, and to ask if this is the case already. Like I mentioned, as an interior designer, I have used it as a kind of interior finish myself. But could you talk more to that on, is it currently in use widespread in kind of people's home environments currently?
It's not as diverse as perhaps I'm sure you and I would like, Alicia. It's happening. There's a fantastic company in Italy, Mogu, who are producing acoustic paneling with like magnetic systems, which are great, and they're fantastic for people who are in white walled boxes in terms of allowing to sort of manage sound. And a lot of companies in the UK, thanks to the Magic Mushroom Company, are now supplying their products in mycelium packaging, which I think probably is the most common thing most people are going to come across as it comes around. Biome have been working to produce certain other objects out of the products in terms of lampshades and all sorts of things. So there is a lot of homeware that is starting to sort of, and interior design products that are starting to bring it into that market.
Brilliant. So we're just about at time. So I wondered if there's any kind of key points you want to end on, key learnings from the project that you maybe want to share with our audience.
I think the key learnings for us is that just do it. I keep saying it, like, it's so important. These materials, these processes, these ideas, these ways of designing, these ways of thinking, they need to move from labs. They need to be put into the mainstream, and they'd be put into the mainstream to benefit us all. And I think the more that we can design to benefit the planet, and the more we can design to put into a circular economy, it really is key. It really is key, and it's totally possible. It takes time, and that's the thing I think most people are scared of, because it's a very we live in a high demand, high turnover, high, everything's fast. Everything has to be fast, and I think we need to look at time, and we need to challenge the people that don't want to take the time to make sure that their products are, reducing impact.
Brilliant. Thank you so much, Simon. So we're just at time now. So thank you so much, everyone, for joining this session as well. And I think there's some other stuff on still. Let me just check in on that. Yeah. So you can join us on the main stage to watch our final talks of the day by Christopher Smith and Dory Tunstall, Dean of Design at College of Art and Design. So thank you so much, and that's it from me today, and I'll see you again tomorrow, and thanks again, Simon.
No, pleasure. Thank you.
Thank you.